So today I've got this Vizio. This one's a smaller one. It's only a 32-inch. Happens to be a VX32L HDTV10A. And the problem that we're having with this one, got it sitting here, there's no stand on this one, so you must have it wall mounted. The logo is amber. When you hit the power button, you can see the logo does turn white. It turns immediately right back to amber. So that tells me that the system control circuit mainboard is probably okay. I don't know quite yet. Let's do some measurements and find out. I'm thinking the next time I hit it though, it does not, oh, it did turn back. It didn't wait long enough the first time. It turns immediately to white, then back to amber. So let's take a look at some power supply voltages first off in this thing and see what we can come up with. Okay, so I've got my voltmeter connected up here. Let's put it on volts. And first thing I'm going to look at is this line right here that is labeled power supply on. I hit the power button. Goes to 3.1 volts, so that's good. I know that the power supply is trying to start. Next thing I want to look at is the next few pins that say 12 volts. It's got no output whatsoever. This is 5 volt standby over here. I should see about 5 volts. These over here are labeled 24 volts. No output whatsoever. Let's make sure this is still, nope, went off. Hit the power button again. Let's see if it'll start. Yep, so let's look at the 24 volts. Nothing. So the power supply is not outputting what it should. It's kind of hard to hear, but I can hear the power supply very lightly squealing in the background. And so let's do a couple checks on this one, see what we can come up with. So I've got my power supply here turned upside down on a piece of foam rubber, so I can plug it in and run it if I want to. I'm going to put this on the diode range, and I'm going to start by checking these 3 transistors right here. 2 of these are the MOSFET metal oxide semiconductor field effect transistors that actually drive the transformer. This is a high frequency isolation transformer, and where this shaded crosshatch area is, this separates the hot side from the cold side of the power supply. So I just want to check these 3 MOSFETs to make sure that none of them are shorted any pin to any other pin. They all look good. Let's check this last one. Now this transistor right here is for the standby power supply. All it does is supply the 5 volt standby. It's a separate power supply. This transistor right here is for the power factor correction circuit that enables these sets to use a little bit less energy than if they just use what's called a voltage doubler circuit. Power factor correction smooths out the incoming 60 hertz signal, so it only draws power on the sine wave as it should, as opposed to drawing power anywhere in the incoming AC. So let's go ahead and check this one, power factor correction. Okay, everything checks good. I don't see any problem. So the next thing I'm going to do is I'm going to put my voltmeter back in volts, and I'm actually going to measure the voltage on the main filter capacitor here. That's the big storage capacitor, and that's part of the power factor correction circuit. And what I want to see on this one is about 350 to 420 volts when the set's run normally. I only see 166 volts, so let's go ahead and hit the power button. And we're still at 165 volts, so that's definitely a problem. I should be seeing, like I said, close to the 350 to 400 volts is pretty much the average for a power factor correction circuit. So I'm going to go ahead and shut this back down, measure the voltage on this. It's already back down to 5 volts, so I don't have any worries about being shocked. Now there's not much to the power factor correction circuit. There's a large transformer here, which is an inductor and a diode. And the field effect transistor actually shorts, very briefly shorts this circuit to ground and then releases it. And it creates a large pulse in this inductor, and it in turn rectifies it across this diode and sends it back into this capacitor. So I've already checked that. Let's check the diode. 0.9 ohms. That is not a good sign. So what I'm going to do, there is a capacitor. I'm going to unsolder this capacitor and see if I get a diode check once again, but I should not have 9/10 of an ohm. If I go in the diode range, I'm sure it's just 0. The difference between an ohm meter check and a diode check is a diode check actually supplies a small amount of current to bias the diode on, and then what you're reading in the display is the actual voltage drop across the diode when it's biased on, as opposed to an ohm meter check applies very, very little current. So there is a difference between the diode check and the ohm meter check on most of these things, most of these meters. So I've zoomed in a little bit there, and what I've done, I don't know if you can see it on the camera right here, but I've unsoldered one lead of this capacitor, and so I'm just going to put my meter back on here. And it does look like the capacitor itself is bad. Let's check the diode again. The diode now checks absolutely fine. 0.432 volt forward drop across the diode. Let's check the reverse bias on it. No, it's good, it's open. So it looks like we might be looking at a problem of this little capacitor C815 on this set. So I'm going to go ahead and unsolder it and take it out of the circuit. So let's go ahead and pull it out of the circuit and check it. Okay, I've got the capacitor unsoldered, and on this one it is up underneath this heat sink, so I'm going to reach in here and try to pull it out. Oh, that one does not look good. It's definitely been overheated, so that one's going to be a challenge trying to find out what the value is. Just for reference, the part number on this power supply, see if I can get it where you can see it on the camera here, 0500-0507-0390. And the manufacturer part number is the DPS-172 CPA. Well, I've done some research based on the manufacturer part number of the chip and on their original data sheet, and they came to the conclusion that they recommend a 220 picofarad capacitor in this application. And so I've got a 220 picofarad at 1000 volt capacitor here because the old one was burned beyond recognition, so I'm going to go ahead and put that into the circuit board here and test it and see what we come up with. Okay, so I've got the replacement capacitor soldered in right here. I just want to measure the voltage on this capacitor. It's 169.7, and I'm going to try to reach over, hit the power button on it, and let's watch the voltage again. 395 volts. That's much better, much more closer to what I was looking for here. Alright, so I've got the setup and running here, and I just want to measure the voltages once again here. So this is, try to do it without disrupting anything. Power supply on, 3.1 volts. 12 volts is 11.85. And this is going to be the 5 volt standby over here, 5.1 volts. And these are going to be the 24 volts to the inverter, 23.5 volts. Everything looks like it's up and running. Let's go ahead and throw the back on it, put a picture on it, and show you the front of it. Alright, so here's the set up and running. Kind of hard to see. I've got it, like I said, the customer did not have a stand on this one, so it's just kind of laying face down here. I got it programming channels right now. Everything seems to be working just fine on it. So a little capacitor overheated, most likely became leaky, started to draw a little bit of excess current, and of course current translates into heat, developed some resistance. The hotter it got, the more current it drew, and the more heat generated until finally it just cooked itself and internally shorted. That was the cause of our problem here. Once again, I wish to thank you for watching this video. Hope I can keep some of these things out of the recycle bin or out of the landfill. Do appreciate, once again, your views, your comments. Try to answer as many as I possibly can, but I can't answer every single one. You can follow me on Twitter, NorCal715. Everybody have a great day, and once again, thanks for watching.